In August 2023, a NASA-funded study published in Cell Stem Cell revealed a hidden weakness of spaceflight: the vulnerability of our stem cells. On Earth, blood-forming stem cells in our bone marrow are the silent guardians of health. They usually remain dormant, stepping in only when new red blood cells, white blood cells, or platelets are needed. This ability to stay at rest protects them from damage, allowing them to regenerate tissues and keep the immune system strong for decades. But in this experiment, scientists sent human stem cells to the International Space Station for up to 45 days. Compared to identical samples kept on Earth, the differences were dramatic. The space-flown cells could not remain quiet. They became hyperactive, burned through energy reserves, accumulated DNA damage, and showed telomere shortening, all molecular hallmarks of premature aging. Why does this matter? Because stem cells are the foundation of blood and immunity. When they falter, the effects ripple through the body. The immune system, for example, depends on stem cells to generate white blood cells. If the supply weakens, astronauts may become more vulnerable to infections. Wound healing also slows down because platelets and immune cells are produced less efficiently. Red blood cell production suffers as well, worsening what NASA already calls space anemia. This can leave astronauts fatigued, short of breath, and less resilient. There are also long-term concerns. DNA instability in stem cells raises the risk of blood cancers. While no astronaut has developed such conditions directly from missions, the risk increases the longer crews spend in deep space, where radiation is stronger and missions may last years. Astronauts themselves have spoken about these physical stresses. Scott Kelly, who spent nearly a year aboard the ISS, described his return to Earth as feeling like aging 10 years in a single flight. He reported extreme fatigue, a weakened immune system, rashes, and slower healing after injuries. His twin brother Mark, who stayed on Earth, showed none of these changes. NASA's analysis confirmed that many of Scott's cellular and genetic markers reflected accelerated aging during his time in orbit. The new stem cell findings help explain why. If the body's most fundamental repair system struggles in space, then every layer of health, immunity, stamina, recovery, is affected. And what about the outside? Could astronauts come back visibly changed? The answer is yes, at least in subtle ways. In orbit, the skin is exposed to constant oxidative stress and radiation. Over time, it may lose elasticity faster, appearing drier, with fine lines or spots forming earlier than expected. The redistribution of fluids in microgravity makes the face look rounder, almost swollen. And when the astronaut returns to Earth, this effect may leave behind new marks of fatigue. Some even report that their eyes seem more sunken, their skin paler, their features slightly aged. These are not science fiction transformations, but real hints of how the human face, the most recognizable mirror of time, can change when life unfolds beyond Earth. And yet, there is room for optimism. Once the stem cells were brought back to Earth, many of the negative changes began to reverse. This suggests that the damage is not permanent and can potentially be mitigated. NASA and its partners are now exploring countermeasures: stronger shielding against cosmic radiation, medical treatments to protect stem cells, and even ways to adjust metabolism so these cells can stay resilient in orbit. As Dr. Catriona Jamieson of UC San Diego, one of the study's lead authors, explained, space is the ultimate stress test for the human body. Studying how stem cells respond under these extreme conditions not only prepares astronauts for future missions, but also offers clues to the biology of aging and disease here on Earth. This discovery, announced in August 2023, shows that the greatest challenges of space exploration are not only external, the distance, the cold, the vacuum, but also internal, hidden in the quiet struggle of our own cells. Understanding and protecting that struggle is what will allow humans to thrive on journeys far from home.